The next concept is compound microscope. Compound microscope. Introduction of that. Compound microscope. Introduction. It is a device. It is a device. It is a device. It is a device. It is a device used to observe the. It is a device used to observe the. It is a device used to observe the highly magnified. It is the device used to observe the. Used to observe the highly magnified image of. Highly magnified image of a tiny object. Highly magnified image of a tiny object, a very small object. T-I-N-Y, tiny object, clearly and distinctly. Clearly and distinctly. Clearly and distinctly. So, compound microscope is a device which is used to observe a highly magnified image of a small object. Right. So, simple microscope in the magnification 1000 times just is. A simple microscope magnified image magnifications compound microscope magnifications time approximately 1000 times jasti magnifications compound microscope. So compound microscope ನಾವು ಎರಡು ರೀತಿ ray diagrams ನೋಡ್ತೀವಿ. ಒಂದು, the image is formed at a least distance of distinct vision, and another one is the image formed at a far point. But the image is formed at least distance of distinct vision, right? So here in compound microscope we used a two convex lens, and those two convex lenses are arranged coaxially. So andre ಎರಡು ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಈ ಒಂದೇ ಲೈನ್ ದಲ್ಲಿ ಬರ್ತೈತೆ, ಅದಕ್ಕೆ ನಾವು ಕೋಎಕ್ಸಿಲಿ ಅಂತ ನಾವು ಕರಿತೀವಿ. ಲೆಟ್ಸ್ ಕನ್ಸಿಡರ್ ದ ಫಸ್ಟ್ ಲೆನ್ಸ್. First convex lens, and its focal length and aperture should be small as compared to the other lens. ಇದಕ್ಕೆ ನಾವು LO ಅಂತ ಕರಿತೀವಿ. LO stands for objective lens. Objective lens ಯಾವುದು? LO. So its focal length is small and it is represented by, this is O, F, O, and the distance between optical center and this principal focus is small FO, focal length of objective lens. ಈ ಕಡೆದು ಕೂಡ F. ಸೊ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ದಲ್ಲಿ ನಾವು ರೈಟ್ ಸೈಡ್ ಇರತಕ್ಕಂತಹ ಫೋಕಲ್ ಲೆಂತ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ಹಾಗಾಗಿ ಫೋಕಲ್ ಲೆಂತ್ ಆಫ್ ದಿಸ್ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇಸ್ ಪಾಸಿಟಿವ್. FO stands for focal length of objective lens. focal length of objective lens. ಡ್ರಾ ಮಾಡಿದ್ರಾ? Focal length of objective lens. Okay. The focal length and aperture of this objective lens is small as compared to the another lens. So compound microscope ದಲ್ಲಿ ನಾವು ಎರಡು ಲೆನ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ ನೆನಪಲ್ಲಿ. ಆಬ್ಜೆಕ್ಟ್ ಸಮೀಪ ನಾವು ಯಾವ ಲೆನ್ಸ್ ಅನ್ನು ಇಡ್ತೀವಲ್ಲ ಅದಕ್ಕೆ ನಾವು ಆಬ್ಜೆಕ್ಟಿವ್ ಲೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಆಬ್ಜೆಕ್ಟಿವ್ ಲೆನ್ಸ್ ಫೋಕಲ್ ಲೆಂತ್ ಮತ್ತು ಅಪರ್ಚರ್ ಇರಬೇಕು, ಕಡಿಮೆ ಇರಬೇಕು. ಎದಕ್ಕಿನ ಅಂದ್ರೆ ಇನ್ನೊಂದು ಲೆನ್ಸ್ ಅನ್ನು ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಆ ಲೆನ್ಸ್ಗಿನ ಕಡಿಮೆ ಇರಬೇಕು. Let's consider a small object which is placed just behind the principal focus of this objective lens. So ಹಾಗಾದ್ರೆ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ರಿ. ಆ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಈ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ದಿಂದ ಜಸ್ಟ್ ಏನಪ್ಪಾ ಅಂತ ಹೇಳಿದ್ರೆ ಹಿಂದ್ಗಡೆನ ಪ್ಲೇಸ್ ಮಾಡ್ರಿ. ಹಿಯರ್ AB is the a small object. Small object is placed just behind the principal focus. So what it means? The object distance is approximately equal to the focal length of the convex lens. So ಹಾಗಾದ್ರೆ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಟು ಈ ಆಬ್ಜೆಕ್ಟ್ ಇರತಕ್ಕಂತ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನು ನಾವೇನಂತ ಬರೀಬಹುದು? ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ನ UO ಅಂತ ನಾವು ಕರಿತೀವಿ. Where UO stands for what? Object distance. Object distance, and this object distance is approximately equal to the focal length of this convex lens, F naught. ಸ್ವಲ್ಪ ಡಯಾಗ್ರಾಮ್ ದೊಡ್ಡದು ಹಾಕೋರ, ಸಣ್ಣದಾಗ ಹಾಕೋಬೇಡ್ರಿ. ಇನ್ನೂ ಬರ್ತಿತ್ತು ಅದ್ರೊಳಗೆ ಡಯಾಗ್ರಾಮ್ಸ್. ಯಾರ್ಯಾರು ಮೂಲೆ ಹಾಕಿರಲ್ಲ ಡಯಾಗ್ರಾಮ್ ತೆಗೆದ ಎಡಕ್ಕೆ ಹಾಕೋರಿ. ಸರಿ, ಫಸ್ಟ್ ನೋಡ್ರಿ, ಆನಂತರ ಡಿಸೈಡ್ ಮಾಡ್ರಿ ಎಲ್ಲಿ ಹಾಕಬೇಕು ಅಂತ ಹೇಳಿ. Let's consider an incident ray which is parallel to the principal axis after reflection. After refraction and reflection, the ray should pass through the principal focus. This is the one ray. Next, consider another light which is passes through the optical center. It will not change its direction. It will go straight. AB is the object. After refraction, these two light converges at this point. Here we get what? Image of the object. Here we get A dash, B dash. A dash, B dash is the image. ಈ ಪಾರ್ಟ್ ಕ್ಲಿಯರಾ? So ಹಾಗಾದ್ರೆ for objective lens, AB is the object and this one is objective lens. The objective lens magnified the object, that is A dash, B dash is the image of the object. This one is real inverted magnified image. Simply. So ಹಾಗಾದ್ರೆ ಮೊದಲನೇ objective lens ಇಂದ ನಮಗೆ ಎಂತ ಇಮೇಜ್ ಬರ್ತೈತಿ? Real inverted magnified image ಬರ್ತೈತಿ. Okay. Now this image is act as the object for the second lens. ಈ ಇಮೇಜ್ ಏನಿದೆಯಲ್ಲ, ಈ ಇಮೇಜು ಎರಡನೇ ಲೆನ್ಸ್ಗೆ ಆಬ್ಜೆಕ್ಟ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡ್ತೈತಿ. Consider the another convex lens whose focal length and aperture is larger than the objective lens. O dash. So this is LE I lens ಅಂತ ಕರೀತೀವಿ ನಾವು ಇದಕ್ಕೆ. I lens whose focal length and aperture is large as compared to the objective lens. ಇನ್ನು ಇಷ್ಟ ಮುಗಿದಿಲ್ಲ. So ಹಾಗಾದ್ರೆ for I lens A dash B dash is the object and we arranged this lens in such a way that the object should come between optical center and principal focus of this eye lens. So ಅಂದ್ರೆ ಇವೆರಡನ್ನು ಕೋಎಕ್ಸಿಲಿ ಆಗಿ ನಾವು ಎರಡು ಟ್ಯೂಬ್ ಎಂಡಿಗೆ ಅರೇಂಜ್ ಮಾಡಿರ್ತೀವಿ ಎರಡು ಲೆನ್ಸ್ ನ. ಸೊ ಅಂದ್ರೆ ಒಂದು ಟ್ಯೂಬ್ ಸಣ್ಣದು ಒಂದು ಟ್ಯೂಬ್ ದೊಡ್ಡದಿರ್ತೈತಿ, ಅವನ್ನ ಎರಡನ್ನೂ ನಾವು ಟ್ಯೂಬ್ ಅನ್ನು ಏನು ಮಾಡ್ಬೋದು, ಈಸಿಲಿ ಮೂವ್ ಮಾಡ್ಬೋದು, ರೈಟ್? ಸೊ ಹಾಗಾದ್ರೆ ಒಂದು ಎಂಡಿಗೆ ಐ ಲೆನ್ಸ್ ಅನ್ನ ಇಟ್ಟಿರ್ತೀವಿ, ಇನ್ನೊಂದು ಎಂಡಿಗೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಲೆನ್ಸ್ ನ ಇಟ್ಟಿರ್ತೀವಿ. ಈ ತರ ಅರೇಂಜ್ಮೆಂಟ್ಸ್. ಇದೊಂದು ಟ್ಯೂಬ್ ಆದ್ರೆ ಇಲ್ಲಿ ನಾವು ಆಬ್ಜೆಕ್ಟಿವ್ ಲೆನ್ಸ್ ಇಟ್ರೆ ಇನ್ನೊಂದು ಎಡ್ಜಿಗೆ ಐ ಲೆನ್ಸ್ ನ ಇಟ್ಟಿರ್ತೀವಿ. ಈ ತರ ನಾವು ಪಿನ್ ಅಂಡ್ ರ್ಯಾಕ್ ಅರೇಂಜ್ಮೆಂಟ್ಸ್ ಅಂತಾನೂ ಕೂಡ ಕರಿತೀವಿ. So ಹಾಗಾದ್ರೆ with the help of the rack and pin arrangements we can adjust this eye lens in such a way that the object A dash B dash should come between the optical center and the principal focus. ಇದರ principal focus ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ FE ಅಂತ ನಾವು ಕರಿತೀವಿ. FE stands for what? That is the principal focus of the eye lens. The distance between O dash and FE is called what? Focal length of eye lens. So the condition is FE is greater than FO. Andre focal length of the eye lens is greater than focal length of the objective lens ಅಂತ ನಾವು ಕರಿತೀವಿ. ಅಂದ್ರೆ ಇದರದ ಫೋಕಲ್ ಲೆಂತ್ ಅಪರ್ಚರ್ ಜಾಸ್ತಿ ಇರಬೇಕು, ಇದರದ ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರಬೇಕು. ಓಕೆ, ನೌ A dash B dash is the object for what? Eye lens. Consider a light which is parallel to the principal axis. After refraction, it passed through principal focus. This is the one light. Consider another light which passes through the optical center of this eye lens. This is another light. So just observe these refracted light. These refracted light will not meet in this side. Therefore, we have to retrace these two lines. So when we observe from here, the light, this refracted light is appear to come from this point. So ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಸ್ಟಾರ್ಟಿಂಗ್ ಹೇಳಿದೆ, ಡಯಾಗ್ರಾಮ್ಸ್ ಎಲ್ಲರೂ ಹೋಗಿ ಮೂಲೆ ಆಗ್ತಕ್ಕ ಹೋಗ್ಬಿಡ್ರಿ. ಈ ಲೈಟ್ ಅನ್ನು ರಿಟ್ರೇಸ್ ಮಾಡ್ರಿ. So here the light converges, virtual light converges. Therefore at this point we get what? final image of the object. A double dash B double dash is the final image of the object. This is inverted. Virtual inverted. With respect to this, remember, idu object anta ನಾವು consider ಮಾಡಿದ್ರೆ this is virtual erect magnified image. Remember, now ಈ object ಅನ್ನು consider ಮಾಡಿದ್ರೆ it is just inverted image. So this is the ray diagram of compound microscope when the image is formed at the least distance of distinct visions. So here the distance between optical center and this final image, the image is formed at a least distance of distinct vision. V is equal to capital D, where capital D stands for what? Least distance of distinct vision. Distance of distinct vision. Least distance of distinct vision. FE ಅಂದ್ರೆ focal length of eye lens. ಡ್ರಾ ಮಾಡಿದ್ರಾ? So the eye lens act as the simple microscope. ನೀನೇ ಡ್ರಾ ಮಾಡಿದ್ವಲ್ಲ ನಾವು ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ನಲ್ಲಿ. ಆ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಈ ಐ ಲೆನ್ಸ್ ಏನಿದೆ ಅಲ್ಲ, ಐ ಲೆನ್ಸು ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತೈತಿ. ಅಂದ್ರೆ when the object is between optical center and principal focus, we get what? Virtual erect image. ಸೊ ಹಾಗಾಗಿ ಈ ಎರಡನೇ ಲೆನ್ಸ್ ಏನಿದೆ ಅಲ್ಲ ಅದು ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್, ಜಸ್ಟ್ ಉಲ್ಟಾ ಡೈಗ್ರಾಮ್ ಆಗಿರುತ್ತೆ. ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಂದ್ರೆ ಡೈಗ್ರಾಮ್ಸ್ ಉಲ್ಟಾ ಮಾಡಿದ್ರೆ ಏನ್ ಬರ್ತಿತ್ತಲ್ಲ ನಮ್ಗೆ ರಿಸಲ್ಟ್, ಆ ತರ ಬಿಹೇವ್ ಮಾಡ್ತಿತ್ತು ಯಾವುದು? ಐ ಲೆನ್ಸ್. Or expression for magnification. Magnification. So in combination of lenses, already we studied the expression of magnification in combination of lenses. The magnification m is equal to, it multiplies the magnification. The magnification done by the objective lens, that is MO, into the magnification done by eye lens is ME. Where M stands for what? This is linear magnification, and MO stands for magnification of the objective lens. Magnification of the objective ME is magnification of the eye lens. This is equation number 1. First case, the magnification done by objective lens, that is MO is equal to just consider the objective lens. This is the objective lens, object, and this one is image, right? So when we consider the height of the image divided by height of the object, that is equal to image distance divided by object distance. When the two triangles are similar triangles, that we can use this formula. So now we baribodu height of the image divided by height of the object is equal to image distance divided by object distance. Use sign convention. HI is negative for this diagram, HO is positive, and object distance is negative, image distance is positive. Substitute these values in this expression. This becomes minus HI divided by HO is equal to V divided by minus U. So minus in ikkade shift madidre HI divided by HO is equal to V by minus in ikkade bantare minus cancel agirtide V by U. So here HI by HO is equal to M V divided by U. For the objective lens, we can write the expression for a linear magnification is image distance V0 divided by U0. V0 divided by U0. So from optical center of this objective lens to image, this distance is represented by V0. And this image is very close to the eye lens, therefore the distance between the optical center of these two lenses is called length of the compound microscope. L anta namu karibodu, length of compound microscope. ಈ ಇಮೇಜ್ ಎಲ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಿತ್ತಲ್ಲ, ಈ ಇಮೇಜ್ ಎಲ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಿತ್ತಂದ್ರೆ ಈ ಐ ಲೆನ್ಸ್ ಗೆ ಬಹಳ ಸಮೀಪದೊಳಗಡೆ ಈ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಿದೆ. ಸೊ ಹಾಗಾಗಿ ದ ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಈಸ್ ಆಲ್ಮೋಸ್ಟ್ ಈಕ್ವಲ್ ಟು ದಿ ಲೆಂತ್ ಆಫ್ ವಾಟ್ ಕಂಪೌಂಡ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಂತ ನಾವು ಕರಿಬಹುದು. ಕ್ಲಿಯರ್ ಬರೆದ್ರಾ? Okay, now substitute the value with the sign convention. Here the image is formed very close to the eye lens, therefore V0 is approximately equal to length of the compound microscope anta bariboda. V0 is approximately equal to length of the compound microscope and its sign is positive, plus L divided by U0 is the object distance, and this object distance is very close to the principal focus, therefore we can write the object distance is approximately equal to focal length of the objective lens, and the sign is negative, minus F. Therefore the magnification done by the objective lens MO is equal to minus L divided by FO. This is the formula of linear magnification done by the objective lens. The second point, the linear magnification done by eye lens. Already we discussed and make a magnification done by this eye lens, because the eye lens is act as a simple microscope. ಈ ಐ ಲೆನ್ಸ್ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ತರ ಆಕ್ಟ್ ಮಾಡೋದ್ರಿಂದ ಈ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪಿಗೆ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಫಾರ್ಮುಲಾ ಲಾಸ್ಟ್ ಸೆಷನ್ಸ್ ಒಳಗಡೆ ನಾವು ಡಿಸ್ಕಷನ್ ಮಾಡೀವಿ. ಸೊ ಅದರ ಪ್ರಕಾರ ಫಾರ್ ಲೀಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ವಿಷನ್ 1 ಪ್ಲಸ್ ಡಿ ಡಿವೈಡೆಡ್ ಬೈ ಎಫ್ ಹಿಯರ್. ದಿಸ್ ಈಸ್ ದ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಡನ್ ಬೈ ದಿ ಐ ಲೆನ್ಸ್. This is equation number 2 and this is equation number 3. Substitute equation 2 and 3 in equation number 1. The total magnification done by this compound microscope, we can write m is equal to minus L divided by FO into 1 plus D divided by FE. This is the total magnification done by the compound microscope. Here the negative sign indicates the final image is inverted with respect to the object. So ಈ expressions ದಲ್ಲಿ ನಮಗೆ ನೆಗೆಟಿವ್ ಸೈನ್ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತಿತ್ತು ಅಂದ್ರೆ m is equal to minus L divided by FO into 1 plus D divided by FE. This is the final expression. The negative sign indicates the final image is inverted with respect to object with respect to object. This is the expression of a magnification in case of compound microscope. So this is magnification when the image is formed at a least distance of distinct visions. Suppose if the image is formed at a infinite, then just we should check this diagram. It means what? We move this eye lens in such a way that the A dash B dash should come on the principal focus of this eye lens. So ಅಂದ್ರೆ ಈ ಐ ಲೆನ್ಸ್ ನ ತಗೊಂಡು ನಾವು ಹಿಂದೆ ಸರಿಸ್ಕೊಂತ ಬಂದ್ರಂದ್ರೆ A dash B dash ಅನ್ನೋದು ಈ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಏನಿದೆಯಲ್ಲ ಈ ಪಾಯಿಂಟ್ ಮೇಲ್ಗಡೆ ಬರಬೇಕು. ಅಂದ್ರೆ ನಾನು ಲೆನ್ಸ್ ನ ಹಿಂದೆ ಸರಿಸ್ಕೊಂತ ಬಂದ್ರೆ ಈ ಎಫ್ ಇ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗ್ತೈತಿ, ಹಿಂದೆ ಬರ್ಕೊಂತ ಹೋಗ್ತೈತಿ ನೆನಪಲ್ಲಿ. ಸೊ ಹಾಗಾದ್ರೆ when the A dash B dash comes on FV, we stop the lens of the eye lens. In that case we get image formed at infinity. With the help of that rack and pinion arrangements we can do that work. Here I draw the ray diagram, rough ray diagram. This one is AB. Here we get A dash, B dash. This image should come on the principal focus of eye lens. In that case, the image is formed at infinity. This is the ray diagram of a compound microscope when the image is formed at infinity. In that case, the magnification formula is m is equal to mo into ma minus l divided by fo into d divided by fe. This is the magnification formula when the image is formed at infinity. ಅದೊಂದು ray diagram ಮತ್ತೆ magnification formula ಬರ್ಕೊಳ್ಳಿ.